Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in the country. This provides quality education at best standards. It provides 100% job placement and assistance. It is the best college in the entire country. St. Andrews offers a variety of courses from B.Tech, BCA, BBA, and they are soon coming up with MBA, Architecture and Law. This is one of the finest colleges that you can get admissions into. The subject I shall be taking in this video is Mathematical Foundations of Computer Science. The code is BCA 108 and this is a BCA second semester subject. The syllabus is in accordance to MDU University Rohtak. The topic that we shall be taking over here is binary search. I, Shalini from BCA department, shall take you forward. Binary search. A binary search is a fast search algorithm with runtime complexity of order of log n. That is linear search. What we did in the previous video. The complexity was order of n, wherein here the complexity is order of log n. This search works on the principle of divide and conquer, wherein you divide into half and then you look at half of the problem and then you again see that if it is done or not. The binary search looks for a particular item by comparing the middlemost item of the collection. So you are comparing the middlemost item. If a match occurs, then the index of the item is returned. If the middle item is greater than the item, then the item is searched in the sub-array of the left of the middle item. Otherwise, it is searched in the array to the right of the item. This continues until the size is reduced to 0. That is, you reach the end of the search. See, if you don't understand what is written, we can see it with an example. So the algorithm is, I set the beginning, that is the lower bound. I set end at upper bound. So the lower bound is at the beginning and the upper bound is the end. And the position is equal to, I initially set it to -1. And I have to repeat the following step until my beginning is less than equal to end. That is, I have to keep on searching. So I set middle point at beginning plus m end by 2, that is half of the entire list. So if my middle is equal to the value, I change my position to middle and I print the position, right? And I go to step 6, that is I exit, sorry. And else what I do, then I compare my middle with the value. If the middle is bigger means my value will be on the, since it is sorted list and the middle is the bigger, so I will send my middle to mid -1 if it is a sorted list with increasing order. So my mid value will be increased to mid minus and will be reduced to mid -1, else my beginning will be, else means my mid, if my middle is larger than the value, I will change my beginning, right? So and then I will print if I don't get anything, right? If I don't get my value, that is if my position at the end is -1, so I will print value is not present in the array. So what I understand, what do you understand? There's a list has a number of elements. What these number of elements are doing, these number of elements are doing nothing, but you are comparing this number of element one by one. No, sorry, you are comparing it with the middle value. If it is value is greater than the middle, you search on the right. If the value is less than the middle, you search on the left, right? When you search on just the left, you will be changed the end. If you shift to the right, you will change the beginning. See, look at in this example. So see, this is a list for 1 5 7 8 13 19 20 23 and 29. I have to find the location 23. So what I do is that I start from step 1, that is 0. So my this thing beginning is 0 and my end is 8. So my middle is by 2, that is my middle value is, I'll compare it with the middle value, that is 4, that is 13. So my value 13 is less than 23. So my, now this time my 0 will get this start beginning will get changed to mid +1, that is 5, right? And my end will remain the same. Now what in my step do I will do, my see my now my this beginning is 5 and my end is this. So now I again compute the middle and my middle is at 20, that is 6 position, that is 5 minus 8 by 2, that is 8 minus 5 is 3 by 2, that is 1 and something, so that is I add 1 2 is that is 6, right? So this add the 2 and then I divide, so 8 plus 5 is 13 by 2 and that amount to somewhere in between 6. So fix, I compare 23, so this 23 is doesn't match with there, then again this is lesser, so I will again change my beginning, right? Again change the, now it comes to 7, so I'll 7 and 8, my middle is 7 and 8, the middle element is 7 and I get at position 23 matches, so my location will return 7, so my position is here, this will be POS will be 7 and my value is, I've searched 23, I was looking for, it is just returning the location of the item. So what is the complexity? See, in the worst cases it is log n, because every time you will compare half of the list. So, and in best case it's in order of 1. That is, first time you took the middle value, you do one comparison and you get it. In average case, it's worst case, both the complexity is log n, which is by far very better than linear search that we did in our previous video, which was log n. So this greatly reduce your computational time, right? So, and it is the dictionary search is basically like a binary search, right? You're reducing, always you're reducing your search space. So this is very good way to actually improve the time complexity. It's a very good searching technique. So then, they can following question be asked, like what is binary search, what is the complexity of binary search. It can ask you an algorithm, and it can even ask you explain with an example. So you need to have all the three. That's all. Take care.